Okay, ladies and gentlemen, welcome back to Mr. Lee Physics class. So today we'll go through the another subtopics. Okay, so we call that is still in the topics of induction, but induction in inductor. Okay, impedance in that is the AC through the inductor. Alternating current flow in the inductor. Let's observe there is a cable that connected to a modem which connect to our computer. The previous technology used cable to connect to the computer, but now we are using the Wi-Fi as well, Wi-Fi or LAN cable to the computer. What happens if the modem without the lightning protection? Observe the window, outside the window. If there's lightning, what happens? If without the lightning protection, so what happens? Our computer will burn and also the modem will be burned. If with the protecting, if with the lightning protection, that means that just the connection before the device before the lightning arrestor will burn. After that, the lightning arrestor will cut off all the circuit and protect our electronic device. In this lesson, you will learn to deduce the phase relationship between current and potential difference for an inductor carrying an alternating current. Objective number 2, to derive the reactance of a pure inductor. Objective number 3, to derive and use the formula for power in a pure inductor carrying an alternating current. Let's observe the next slide. When an alternating current is connected to a solenoid, a series of coins, where it's connected to a zero center ammeter, which used to measure the alternating current, and the potential difference, the voltage across the solenoid. Now, when switch on, observe the change. When the voltage is maximum, current is 0. When the current is 0, the voltage should be maximum. Observe or not? So this means that the current and the voltage, the current and the potential difference, they will have some phase difference. Now we observe that when an alternating current which pass through a solenoid, so what will be happen? The I is equal to I naught sin omega t. Then the EMF induced, that means EMF will be equal to negative L di over dt. Hence, we get that the EMF induced in the solenoid will be equal to negative omega L I naught cos omega t, where the voltage is equal to the V, right? So it's equal to the EMF or the potential difference in the solenoid. So hence we get that V, the potential difference, will be equal to omega Li naught cos omega t. So V, that means that V is equal to omega Li naught will be equal to omega Li naught will be equal to the EMF, right? V naught, right? So that means V will be equal to V naught cos omega t, maximum voltage. That means it will be the EMF. So That means that we get that V equal to, once we want to convert cos omega t into sin omega t, that means that V naught, okay, is equal to sin, V is equal to V naught sin omega t plus pi over 2. So that means that the phase difference will be pi over 2. Why this one? If V not equal to cos omega t, sin and cos, what are the difference? The shape, the graph of the sin and the graph of the cos, the difference just pi over 2. That means that it will be, the difference will be how much? Okay, pi over 2. So from here we notice that we convert to sin because we want to compare the phase. Once I equal to I naught sin omega t, V equal to V naught sin omega t plus pi over 2. That means that pi over 2 will be the phase difference. And then we notice that how is the difference in the graph I and V. Now we notice that when the V equal to V naught cos omega t, V equal to V naught cos omega t, that means this will be the shape, the graph of the cos shape. I equal to I naught sin omega t sin omega t. If I convert it to the what's that? To the sin omega t, that means that this graph I need to move it a little bit to right side. The red color need to move to right side so that it will become sin, right? So how much difference? That means the difference will be equal to 45 degrees. 45 degrees, that means that pi over 2. So the phase difference will be equal to pi over 2. Okay, as a short summary, if I equal to I naught sin omega t, then the V will be equal to V naught cos omega t, where V naught will equal to omega L I naught. And the phase difference between the current and voltage is pi over 2 radian, the phase difference. The voltage leads the current by pi over 2 radian, or the current lags the voltage by pi over 2 radian. Who lags? What is meant by lags? Lags means that slower. Lead means that that means that it's in front. Okay, so voltage lead current, voltage front, then current behind. Voltage is front, current behind. Okay, so that means that the voltage is faster, it's leading the current. Okay, voltage is leading the current with pi over 2. Okay, so if this one move a bit, will move to right side a bit, we'll have the shape of the eye of the sin. That means that this one is moved forward, move to right. That means now it's moved to right side, right? This one, same compared to the blue color. This red color is moved to left side. Move to left side, that means that it's leading. Which one move to left side is leading? Move to right side will be lag. We consider is lag. Okay, now we look at the next slide. Next slide show that compare the difference between the alternating current in a resistor and alternating current in a solenoid. Ladies and gentlemen, I equal to I naught sin omega t, I is equal to I naught sin omega t. For the circuit 1 and circuit 2. What are the difference? That means that before that is current and the potential difference are are in the same phase for resistor. For the solenoid, that means that for the solenoid, which one lead the voltage lead the voltage lead the current in the inductor. So that means that the voltage leading with pi over 2 to the current, or the current lag the voltage with the phase difference pi over 2. And next, we notice that for a solenoid or inductor, once the current flow is I equal to I naught sin omega t, V is equal to V naught cos omega t, V equal to V naught cos omega t, or V equal to V naught sin omega t plus pi over 2. Okay, so from here, the reactance, that means that will be the resistance for the inductor. Okay, the concept of resistance for the solenoid. So the reactance of an inductor or induced reactance SL is defined as XL equal to V over L. That means the concept XL is like the resistance, right? So where V naught is the peak voltage across the inductor and I naught is the peak current. The unit for reactance is ohm. This means that the reactance is a type of the resistance. Ladies and gentlemen, since the XL equal to V naught over I naught, where as we know that V naught for the EMF, maximum EMF or maximum voltage will be equal to omega L I naught. Okay, so that means that hence XL will be omega L I naught over I naught. At the end, we get that it will be omega L. Okay, hence the R is equal to omega times with L. So XL is equal to V naught I naught. Hence, we get that V naught over square root of 2 divided by I naught over square root of 2. XL is equal to VRMS over IRMS. It can be V naught over I naught or VRMS over IRMS. So this means that the reactance or the resistance, the reactance will be equal to V over I, the ratio of V over I. If we use the V naught, we use the peak voltage, that means divide by the peak current. If we use VRMS, that means that it will be divided by I, the IRMS. That's all. Next. For an inductor, once the current flow, okay, let's say when the current flow through the, any question? When the alternating current flow, that means that let's say the inductor with L inductance. Okay, so we get that the current flow is 4 ampere. What happens if I replace it with the coin? Which coin? The size of coin is bigger. So that means that the bigger the coin, the current will reduce. Okay, for the frequency, if I select the frequency, that means that once the frequency increase, the current will reduce. So now you see, if I reduce the frequency, that means that the current is increased. Okay, in Asia, the alternating current is 50 Hertz. Okay, so that means that once we reduce the frequency, That means that the current is increased. Ladies and gentlemen, let's look at the slide. I naught equal to X naught or equal to V naught over XL, where V naught over 2 pi FL omega L. Yeah. So that means that angular because it's in the what is that? The alternating current is in angular form. So that means omega is equal to 2 pi F times with L. Since I is directly proportional to IRMS, so IRMS is inversely proportional to the frequency. Okay, ladies and gentlemen, as here we notice that the IRMS is inversely proportional to the frequency. Once the frequency increases, the IRMS will reduce. As a conclusion, we notice that the opposition of an inductor to the flow of alternating current is called the reactance of inductor, the concept of resistance. Easiest, in other words, we said that that is the resistance for the inductor. Next, XL is equal to V naught over I naught. That means that the peak voltage over the peak current, or VRMS over the IRMS. Next, XL will equal to omega L, which equal to 2 pi FL. Therefore, the unit for reactance is ohm. Next. Okay, next for the AC power supply. Supply through a lamp and through a lamp dimmer. That means that this is the control. To control the brightness of a lamp. So once I turn the switch, we notice that the brightness of the bulb reduces until it's almost go off. But when I turn again, we notice that the intensity increase. Okay, so what happened inside the dimmer? Actually, when I turn, that means it's moved further. The iron rod, once the iron rod is away from the inductor, that means that the brightness is maximum. Once it's nearer, that means that where it's inside, the brightness almost gone. That means that the current almost gone. Okay. Okay, look at the graph and the voltage. The voltage leading the current. Okay, so from here, for the blue curve will be show the current. The red curve show the voltage. How about the power? You see power maximum and zero. That means anything P is equal to IV, right? That means that it will be zero. Okay, maximum and zero, again, it will be zero here. So at the end, we notice that the power will be like that. The black color show that that is the power of the inductor. So P is equal to IV. I naught V naught, I is equal to I naught sin omega t times with V naught cos omega t. That means that I naught sin omega t times with V naught cos omega t. As a result, we get that I naught V naught over 2 times with sin 2 omega t. So the power of the inductor will be equal to I naught V naught, the I peak current times with peak voltage divided by 2 sin 2 omega t. Let's look at the graph. The graph shows that from A to B, B to C, C to D. Okay, there will be the current and the power. When we move, we notice that what happened? The shaded area show that, okay, we again from here, okay, from A to B, we notice that the magnetic flux through the inductor increase. When B to C, that means that the magnetic flux decrease. The magnetic flux density decrease. Then here, the magnetic flux increase again. That means that for the positive region means that the magnetic field induced in the solenoid, where the strength of the magnetic field is increasing. Okay, so the cross section, I was at the area under the graph. The area under the graph show that the intensity. Positive show that it's increasing the production. Negative means that it is reducing. Okay. So, ladies and gentlemen, as a result, we notice that P is equal to I naught V naught over 2. And the mean power in the inductor is 0. Next, there is no energy dissipated as heat in a pure inductor carrying an alternating current. Okay, so that's all for today's lesson. So next, I want you all to do the question for today's lesson. Ladies and gentlemen, for the today's lesson, the question here are the questions. We have question 1, question 2, question 3, question 4, question 5, question 6, question 7, and question number 8. Question number 9, last question number 10. Ladies and gentlemen, please solve the question before you check the answer. The question, I will post in our Telegram group, then together with the answer. Please solve the question and we discuss again after that. So, ladies and gentlemen, that's all for today's lesson. So, see you on next lesson.